Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing design of synchronous decade counter. The topic is from sequential logic circuit. The subject name is digital electronics. The problem is design synchronous decade counter. Decade counter is also known as MOD-10 counter using T flip-flop. In this class we will be seeing design of decade counter using T flip-flop. So, in our previous classes we have seen while designing a synchronous counter we need a state diagram. So, we have drawn the state diagram. Decade counter or MOD-10 counter, it means it is having 10 states. The MOD-10 counter is counting from 0 to 9, after 9 it is going back to 0. So, this is a state diagram of MOD-10 counter. So, after 0 state it is going to 1, then 2, 3, 4, 5, 6, 7, 8, 9, after 9 it is going back to 0 state. So, total 10 states are there. How many flip-flops will be required for design of MOD-10 counters? How can we know? By knowing the largest state. Here the largest number is 9. For representing 9 in binary we require we write it 1001. So, 9 is represented by 4 bits. It means we require 4 flip-flops for the design of MOD-10 counter. And here we are using T flip-flop. So, the flip-flops will be TA, TB, TC and TD. So, TA output will be QA, QB, QC and QD. Okay, after drawing the state diagram we need to go for the transition table. The transition table is comprising of present state, next state and flip-flop inputs. Present state means the flip-flop outputs are written QA, 4 flip-flops you are using. So, their outputs we have written in the present state QA, QB, QC, QD. What will be their next states? QD next state will be QD plus 1, QC next state will be QC1, QC plus 1, QB next state will be QB plus 1, QA next state will be QA plus 1. The first column is present state, next column is next state. The third column is flip-flop inputs. How many flip-flops? TA, TB, TC, TD. So, you have to be very careful while writing this transition table, because the students they write it, suppose if they are you can write the sequence like this also QA, QB, QC, QD, but I have taken the direction as QA, QB, QC, QD. And here a QA plus 1, QB plus 1, QC plus 1, QD plus 1. Then in the same way QA is in the last year, so QA plus 1 and then the last year is TA. So, if you are using here QA, so here it should be QA plus 1 and here it should be TA. So, the sequence you can take it as per your choice, but you have to take it in all the 3 columns in the same way. If you are proceeding in this way, QA, QB, QC, QD, QA plus 1, QB plus 1, QC plus 1, QD plus 1, TA, TB, TC, TD. This sequence is important, do not mix it. Okay, so, let us start the transition table. So, for filling this transition table you must know what is the state diagram. So, for 4 states, how many binary sequence we can write? We can write total 16 states, that is starting from 0, 0, 0, 0 till all 4 ones. So, that is written here 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1010, 1011, 1100, 1100, 1101, 1110 and all ones. So, we have written all the total 16 binary combinations here, starting from 0000 till 1111. Okay, now we know the state diagram. After 0 state, what is coming next? 1. You know this state diagram. After 0, what is the next state? 1. So, we need to write the next state here in binary. This is 0 0 0 means this is a 0 state. After 0 state, what will be the next state? 1. 1 is written as 0 0 0 1. What is this one? 1. After 1, what is the next state? 2. How is 2 written? 0 0 1 0. This is 2. After 2, what is the next state? 3. 0 0 1 1. After 3, this is 3. So, you can write it in decimal form if you are not very thorough with it. This is a decimal 0, 1, 2, 3, 4. After 3, what is the next state? It is 4. So, after 3, the next state is 4. So, 4 is written as 0, 1, 00. This is 4. After 4, what is the next state? 5, 0, 1, 0, 1. And after 5, what is the next state? 6. 6 is 6, 0, 1, 1, 0. And this is 6 in decimal, this state. After 6, what is the next state? 7. 7 is written as 0, 1, 1. And this is 7. After 7, what is the state? 8. 8 is written as 1, 000. And this is 8 in binary, 1, 000. What is the next state after 8? 9. 9 is 1, 0, 1. This is 9. After 9, what is the next state? After 9, it is 0. Okay, so this I have written based on the state diagram, because after 9, what is the next state? 0. So, this I have written it here. So, this is after 9, where it is going back to 0 state. Okay. Now, when 1 0 1 0, what is this one? 10. This is 11, 12, 13, 14, 15. So, do we have this 10, 11, 12, 13, 14, 15 in our state diagram? If you look at this state diagram, do we have 10, 11, 12, 13, 14, 15? No. So, as these states are not there in the state diagram, we need to take them as don't care states. So, their next states will be don't care states. Okay. So, after 10, the next state will be don't care. So, we put all cross sign, and after 11, the next state 10, 11, 12 and 13, 14 does not exist. So, put them don't care. Okay. So, like this we can put all cross because they do not exist in the state diagram. X indicates the don't care states. Okay. So, what we have done now in the transition table, we have completed the present and next state. Now, we need to fill this third column, that is the flip flop input. How can we fill this column? If you know the transition, if we know the excitation table of T flip flop. What is excitation table? This one. The excitation table consists of Qn is the present state, Qn plus 1 is the next state. For these two inputs, we need to write what is the state of T. So, for two inputs Qn, Qn plus 1, present state, next state. How many possible combinations? 4. That is written as 0 0, 0 1, 1 0, 1 1. So, how to fill this T column? It is very easy to remember. Whenever there is a transition, that is, if you look here from 0 to 0, there is no transition. So, the T is 0. From 0 to 1, there is change, there is a toggle. From 0 to 1, there is a change. So, we put T as 1. From 1, it has change the state to 0, there is a change. So, we will write the t as 1. From 1 to 1 there is no change. So, we take it as 0. So, these two are known as toggle state, and this is no change state. So, it is easy to remember the T excitation table. Whenever there is a change from 0 to 1 or from 1 to 0, the T will become as 1. So, let us now fill this flip flop inputs in the transition table. So, let us fill this TD column first. So, we need to compare this QD with QD plus 1. So, if you compare this one, this is 0, this is 0, no change. For no change, the output will be 0. Now, for 0, 0, no change. So, T will be 0. Now, for 0, 0, no change, 0, 0, 0, no change, 0. Okay, so we can easily see this one. So, QD is all 0 till 7 and it is all 0 till 6. So, till 6 both are 0, 0. So, we can till 6 up to here we can put all zeros. Now, from here at 7th state it is one is 0, QD is 0 and other one is 1, this one. For 0, 1 there is a change. So, the output T will be 1. Now, here the T is 1, QD is 1 and QD plus 1 is 1. So, there is no change. This is 1, this is also 1. So, it becomes no change. So, it becomes 0. Now, coming to this 9th state, this here it is 1 and here it is 0. 1 and 0, there is change. So, when there is change, what will be the T value? It will become 1. Now, coming to from 10, now coming for this 10 to 15, 10 to 15 we see this QD plus 1 column is all don't care. So, there is no we write the excitation table for 0 and 1. Na? So, for all this is 1, this is x. So, in this case when the other column is all don't care, so we put them simply don't cares like this. Okay, like this. Now, let us fill this TC column. So, to fill this TC column, what we need to do? We need to compare QC with QC plus 1. Now, see what is this? This is 0, this is 0. For 0, 0, what should be the output? 0. This is 0, this is 0, output is 0. 0, this is 0, 0. This is 0, this is 1. What will be the output here for T? 0 and 1, it will be 1. This is 1, this is 1, no change, so 0. This is 1 and again 0. 1, 1, no change, so 1 no change means 0. Whenever there is change, only that time we need to put this is 1. This is 1 and this is 0. So, what will come here for 1, 0? It will come as 1 because it is toggling. Next state is 0, 0. For 0, 0, TC will be 0. Now, for 0, 0, no change, so it will be 0. Now, from 10 to 15, what we can write? All are don't cares. So, from 10 to 15, all are don't care. Okay, now let us see the column for TB. For filling the column for TB, what we need to see? QB and QB plus 1, these two columns. So, now for the first state, both are 0, 0. 0, 0 means no change, so it will be 0. 0, 1. For 0, 1, 1. 1, 1, no change, so 0. This is 1, 0, change, 1. 0, 0, no change, 0. 0, 1. For 0, 1, 1. For 1, 1, no change, 0. So, this is 1, 0. For 1, 0, there is change, so the output is 1. For 0, 0, no change, so it will be 0. This is 0, both are 0, 0. So what will be the output? 0. Now from 10 to 15 all are don't care. So we have put cross sign there. Now let us fill this TA column. For filling the TA column we need to see TA with QA with QA plus 1. Now come see this one Q0 1, 0 1 there is a change, so it will become 1. For 1 0 there is a change 1, 0 1 change 1, 1 0 change 1, 0 1 there is a change, so it is 1. For 1 0 there is a change, so it will 1 0 1 1, 1 0. For 1 0 it will be 1. This is 0, this is 1, 0 1, so it will be 1. This is 1, this is 0, it will be 1. So from 0 to 9 TA is all 1, and from 10 to 15 what will be the outputs? They are don't care. So we put them cross sign, because this QA plus 1 column is all don't care, because 10, 11, 12, 13, 14, 15 states doesn't exist in the state diagram. So in this way we could fill the transition table, which is comprising of present state, next state and flip-flop inputs. So once you have completed with this flip-flop inputs, we need to now simplify the K-map for TD, TC, TB, TA. Okay. So to fill the solve this K-map, we can draw this 4 variable K-map, which I have drawn it here to save the time. The variables here are QD, QC, QB, QA, that is 0 0 0 1 1 1 0 1 1, 0 0 0 1 1 0 1 1. And we know the cell numbers. For our convenience, let us put them in small numbers. 0, the cell numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like this. Okay, after filling this one, now let us see this TD column. So where do we find ones? So we find in TD column we find 1 at 7, and at 9. Only at 7 and 9 we are having 1 1, and from 10 to 15 all are don't care. So for TD it is 1 at 7 and 9, this is 9, and is don't care from 10 to 15. So where is 10 here? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is 10. From 10, 11, 12, 13, 14 and 15, all these are don't cares. So TD is 1 at 7 and 9, and from 10 to 15 all are don't care. So what possibility of pairing is possible here? We can make one quad here. What is this quad name? So for this two we need to look here. Here 1 is common. What is 1 here? QD. For these two, what we have to look for these two columns, what is common? 1. So what is 1 here? QA. So for this quad, the term coming to be as QD QA, and we can form one pair here. So for this pair we need to look at this column. So the column name here is QB QA. plus we need to look it for these two rows, one is common. So what is this pair name? It will be QB, QA. In these two rows, one is common. What is one? That is QC. So we will get QB, QA, QC. Okay. So we are getting one quad and one pair for this TD. The equation for TD is coming to be as QA, QB, QC plus QA, QD. This, now let us see this TC column. It is 1 at here, this is 3 and is 1 at 7. So TC is 1 only at two places, that is at 3 and 7, and from 10 to 15 they are don't care. So let us, this is TC is 1 at 3 and 7. Okay, so TC is 1 at 3, 7, 10, 11, 12, 13, 14, 15 are don't care. So we can make one quad here. For this quad, the name of this quad is QB, QA. Okay, so what is TC coming to be as? TC is coming to be as QB, QA. Okay, now let us see for TB. So here TB is 1 at 1, after 1, 3. If you look here, it is 1, 3, 5, 7. At 1, 3, 5, 7 they are ones. For TB it is 1 at 1, 3, 5, 7, and from 10 this is 10, 11, 12, 13, 14, 15 are don't care. So we can form one quad here for this. Okay, so for this quad, it is answer is, in this the common is 0, that is QD bar, and here 1 is common, so it will be QA, QD bar. Here 1 is there, what in these two columns 1 is common. So what is 1 here? QA. In these two rows 0 is common, that is QD bar. So for TB what is the answer? It's coming to be as, it's coming to be as QA, QD bar. Okay. Now coming for TA, we have seen in TA from 0 to 9 state all are 1. So we have filled ones, 0, 1, 2, 3, 4, 5, 6, 7. 8, 9. At these places they are 1 in the transition table. 10, 11, 12, 13, 14, 15 are don't care. So here we can form a quad like this, not quad, it is octet. Okay, so we can form a octet for TA. So when full is covered, what is TA now? TA will be equal to 1. Okay, so we have simplified all the 4 K maps for TD, TC, TB and TA. Now let us draw the logic diagram for it. For drawing the logic diagram, we need 4 flip-flops. So the 4 flip-flops are TA, TB, TC, TD. TA output is QA, QA bar. TB output is QB, QB bar. TC output is QC, QC bar, TD output is QD, QD bar. Let us in this negatively edge triggered, so we put a bubble. It is a design of a synchronous decade counter. So what we need to do? We need to give the same clock pulse to all the flip-flops. Okay. So how to draw this logic diagram? So for that we need to know what are the equations we got it here. For TD what we got? For TD we got the equation as QA QD plus QA QB QC, and for TC we got the equation as QA QB. For TB we got the equation as QA QD bar, QA QD bar, and for TA we got the equation as 1. So based on these equations, now we can draw the logic diagram. Okay. So what should be TA connected to? As per this equation, TA is connected to 1. What is TB connected to? TB is connected to QA QD bar. So we need to connect here a AND gate. The output of this AND gate is coming to TB. What are the inputs for this? For TB the inputs are QA QD bar. So here the one of the input is QA, another input should be QD bar. So another input we connect it from to QD bar like this. For TC it is QA QB. We need one AND gate for TC. One input is TA. So we will darken this point of TA to tell that this QA is going for TC. So QA came. What else we need? We need QB. Because what is TC? TC is equal to QA QB. So we have taken QA and QB and given to TC. Now to draw TD, we need two AND gates and then OR it, plus sign. So we need two AND gates and then OR gate to it, whose output is going to TD like this. Now what are the inputs to this TD? QA QD. So this is already coming up to here. From here we can take and tell here. Okay. So this is QA. Another one is QD. So another one should come from QD like this. QA QD. Now we need three inputs to this AND gate. One is QA, QB, and another input is QC. What is the output here? QA, QB, QC. The output here is QA, QD. Okay, so in this way we can easily draw the logic diagram of TA of MOD-10 synchronous counter. Outputs we can extract from QA, QB, QC and QD. Very important point to be noted here while drawing the logic diagram is we must darken the points from where we are connecting, or else if you do not darken, it means that it is not clear that this line is going to this point or to which point it is going. And it will be more convenient if you write the outputs here. The output of this QA, that is TB input, is QA QD bar. This is here QA and QD bar, and for this one for TC the inputs are QA QB, like this. Okay. So, I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.